All right, so 3.4, section 3.4, Foundations of Math 30, applications of set theory. So we are talking about set theory, and we've been talking a lot about Venn diagrams. We've been talking a lot about principle of inclusion and exclusion. So there's sort of the Venn diagrams, right, with the, that would be sort of the visual. This is number 15 from 3.2 that we just went over in class from the last assignment. And this would be sort of option one, where you work with the Venn diagram, you put in the numbers and just kind of use intuition to solve. Over here, okay, we're talking more about the notation and the algebra, and some of you may gravitate towards working primarily with the Venn diagrams and trying to put numbers in the regions. Some of you may just say, you know what, I'm just going to do the algebra and do the math, set up the equation, that's better for me. I'm going to show you sort of both methods here in 3.4, and 3.4 is applications of set theory, and the big difference with 3.4 is that we have 3 subsets in our Venn diagrams now. We've been primarily working with just 2 subsets, right? So we're going to work with 3 subsets in some of these questions, 3 subsets in Venn diagrams now. And I'll start off with the example on page 179. Investigate the math. So let's just bring that up. Okay, so in your textbook should look like this. There's 3.4, and the investigate the math here is going to look like this. So let's take a look at this question here. It says Rachel surveyed grade 12 students about how they communicated with friends over the previous week, and we're talking about percents here, which we haven't talked about percents before. But what you can do with percents, you know, that's per 100, right? So it doesn't matter actually how many students were interviewed. If you see a percent, you can assume that this is 66 out of 100. So when we're doing our Venn diagram, if we're just talking about percents, you can use all these percents and then just assume the universal set contains 100 items, okay, 100 elements. So you'll see as we move through this question. 66% called on a cell phone, 76% texted, 34% social networking, 56% called a cell phone and texted, 18% called a cell phone and used social networking, 19% texted and social networking, and 12% used all 3 forms of communication. Okay, so in this survey, this is sort of what shook out. Now, a little hint when you're doing these questions, because these are the types of questions that you'll have to do for 3.4, putting this all together. It's a good idea always to start with the section in the middle, the intersection of all of these subsets. Okay? That's the best place to start. Okay? So you might want to just jot that down as a note. When you're filling in your Venn diagram, start with the intersection of all 3 sections. Alright, so that 12%, if we look at this, 12% used all 3 forms of communication. So which region would represent that 12%? Where would I put the 12? Anybody? Right here? Would I put it right here? No. Would I put it right here? No. What about here? And what about here? Did I hear yes? Very good. Okay. 12. You guys don't really like contributing to the discussion, do you? Or is it too early, maybe? First period? Okay, yeah. Okay, good. Okay. That was some enthusiastic nods there anyway. So yeah, okay. All right. So note to self, don't ask students any questions first period. Okay, good? All right. Okay, so the 12 goes there. Now, why is that important? Because, you know what, we're going to be able to work out from here, because other information, like, where is this one? Okay, so let's work up. 90% texted and uses social networking. So on this diagram, if this is cell, this is text, this is social networking. Okay, where does this 19% go? Texted and use social networking. Well, here's the T circle right here, and here's the social networking circle. So the overlap between those 2, okay, it's not just this part right here. It's not just this. It's actually the whole thing. You see that? The intersection of those 2 circles. So the 19 people are actually going to be in this whole region here. And I already have 12 placed here. So what I'm going to do is I'm going to put the remaining 7, so 19 minus 12 is 7, goes right here. Okay? I'll put that in black. So does everyone understand that? So we've got these first two down here taken care of. They are appropriately placed in the Venn diagram because 12 have the intersection of all three, and 12 plus 7 would be this part right here. That's the intersection of T and S. Got it? Good? Okay, you can probably go ahead of me here now even, but the next section, 18, called on a cell phone and social networking, so S and C, that is 18. So we've already got 12 in this region. So in this part, I write 6. Does that make sense? Okay, because 18 have to be in this region right here. I won't ask whether you get that or not because I know you're not going to answer me. But you can nod your heads maybe. Do you get that? Nod or shake. Okay, good. Lots of nods. Okay, so that's 18. Awesome. 56% called on a cell phone and texted. Okay, so there's a pretty big number there. So cell phone and texted, that's these two circles right here, 56. So I've already got 12 in there. What do we need to put in this spot? 44? All right, so we've got that 56 taken care of. That's 44 plus 12. 34% used a social networking site. Okay, so in the social networking site, that's just the S part right here, okay, has a total of 34. So look at what we already have in the circle. See that? So we had 6 and 12 is 18 and 7 is 25. So 34, what's going to go in this section right here? 34 minus 25 is 9. All right? So you'll find that working out is pretty good because if you started with 34% here, if I started with 34, then as I move down the list, you're going to have to, oh, that 34 is now going to come down when I put this, 7 in here, and it's going to come down again when I put the 6 over here, and, it's just going to be a lot of, changing things. So I would start from the middle. And then, of course, as we move up, 76% texted. Okay, so in total, 76. So we've got 44 and 12 and 7. So that's 13 left over there. And 66% called on a cell phone. So 44 and 12 and 6. Looks like there's only 4 left over that only used a cell phone. So we can now answer a lot of questions regarding this situation, like, well, the one I just answered, I guess. How many students only texted this week and did not, or sorry, well, yeah, we answered that one. How many students only texted this week, did not use a cell phone to communicate with their friends, and did not use social networking sites? That's 13. Okay? All right? So, and of course, 6 would be the students that used cell phones and social networking sites but did not text. That's 6 right here. Okay? Do you have any questions about that right there? Okay. All right, so example number 1 in your textbook, page 180. We're going to do this, and we're going to talk about the algebraic sort of notation method of doing this, okay? Because it's important for you to see that as well, and so that you know how to do that. So in this question, it says this: use the following clues to answer the questions below. The first question, let's just skip down to the question. How many children, so we're looking for the number of kids that have a cat, a dog, and a bird, okay? So if you're thinking Venn diagram, if you're thinking this diagram, you're thinking, okay, there's some kids that have cats, some that have dogs, some that have birds, and obviously there's some that have all 3. And so we got 3 circles that are going to overlap, all right? Now, we're not going to draw the Venn diagram right away because I want to show you the algebraic sort of notation method. These are the clues. 28 children have a dog, a cat, and, a dog, a cat, or a bird, okay? So what's that? A dog, a cat, and a bird. That would be the number of kids that have a bird, or a cat, or a dog. Does everyone see that? That's the total number. The key word is or there. This one says and. See that? This is or, so that's union. This is and. So we could actually put down here what we're looking for. This is the number of bird and cat and dog. Okay? All right, we good with that so far? Okay, so 13 children have a dog. All right, so what's that going to be? 13 children, that's going to be the number of kids that have a dog, right, in the dog circle. 13 children have a cat. So that's going to be the number of cats. Number of cats, number of kids with cats. 13 children have a bird. Okay, so that's the number of birds. So identifying, what these statements are is important. 14 children have only a cat, only a dog and a cat. So how do we write that one? That's going to be what? Only a dog and a cat. So that's going to be, dog and cat, but what's going to go in between there? Is it going to be a or a union or an intersection? Intersection. Okay. So that's going to be dog and cat. Okay. And 3 children have only a dog and a bird. So number of dog and bird. 2 children have only a cat and a bird. Okay. So this is the number of cat and bird. Only. So if you're thinking Venn diagram, you're thinking of the different regions that these numbers are going to go in, right? And there's no child that has 2 of each pet. So that's just going to make things easier that we don't have to double, there's going to be, for each animal, there's going to be basically a kid, okay? They're going to only have 1 of each animal. All right, so how many children have a cat, a dog, and a bird? Okay? So it's helpful for me, and we're not going to use the Venn diagram, but I want to visualize it, okay? So if I'm thinking Venn diagram, I'm thinking this. I'm thinking there's 3 circles, and they're going to intersect, okay? What I'm looking for is this little part here, right? If we've got B and C and D, I'm looking for this little part here, and that's a little X I've got in there. So that's kind of unknown. And that's going to be, this right here is going to be the unknown, okay? The intersection of all 3. All right, so if we're trying to find this right here, okay, how do we go about writing an equation for this, okay? And this is the way I'm going to suggest that you do this, all right? So all of this, B, C, or D, okay, is going to be the number of B or C or D. All right? Now, how would we find that? Well, we obviously have to add the number of B's plus C's plus D's. We need all 3 of those circles. So a number of B plus the number of C plus the number of D. But we've double counted some things, right? And so what we have to do is we have to say, well, I know that I've double counted some things. And actually with a Venn diagram that has 3 circles, and let me just blow this up here for you a little bit. Just going to make this a bit bigger so we can see it. Okay, for this Venn diagram here, we have double counted several things, right? We've double counted this part, we've double counted this part, and we've double counted this part, right? So we need to take those away, just like we did last section. So we're going to take away the number of B and C. So that's going to be this section here. We're going to take that away. We are going to also take away the number of C and D. That's this one here. We're going to take that away. And we're going to take away this overlapping section as well. That's the number of B and D. Now my question is, are we done or not? So does that make us count everything just once? And if you noticed here, we actually took away this section here. So I'll just maybe highlight that. This middle section here, we actually took that away too many times, didn't we? So we've double counted this, but I've taken it away a number of times. This is actually overlapped on the takeaway. So what we have to do, the final step is, we have to add back in this intersection part. That's where this comes in. So the number of B and C and D. We have to add that back in because we've taken it away too many times. Okay. Any questions about that? I know that's maybe a bit complicated, but let's think about it again. We've got all the B's, all the C's, and all the D's. Let's take away the double counting between each of the three sets, but we have to add back in that innermost set. And actually, this is what we're going to be solving for. Okay? That's what we're going to be solving for. So we have to rearrange this equation now. Right? And with the fact that this is an X, it's going to affect a little bit how we label this stuff. So why don't we fill in some values here? Okay? So the number of B or C or D. Do we have a number for that one? How many in total? That's 28. You see that right here? That's 28. So we write down 28 here. What's the number of B? The number of B. Kids that have a bird, 13. What's the number of C? Kids that have a cat, that's 13. What's the number of D? Dog is also 13. How many kids have a bird and a cat? A bird and a cat. So where's that? Bird and a cat is 2. Okay. Now, the only problem is a bird and a cat. Look at this. We have to adjust this. Let me just erase some of this stuff. Stay with me here. This is a long question, I know, but I just need to clean this up for you a little bit. Remember, we have our X in here, right? So a bird and a cat is all of this right here. So it's actually going to be, because this is bird and a cat only. So this is 2 is right here. See, cat and a bird only. So guess what? Bird and a cat is going to be 2 plus some of the kids that have all 3, which we haven't counted yet. So this is actually going to be 2 plus the unknown part. So that's where it gets a little bit tricky here with these X, Y. And you're going to have questions that are just like this. So you're going to do, this process exactly. So we got to minus the 2 plus the unknown part. Okay, so the number of cats and dogs, okay, is, where's that? Cats and dogs right here. There's 4 kids that have cats and dogs, and there's 4 that have only cat and dog. So this whole section is going to be 4 plus X. And then bird and dog is 3, so only bird and dog. That would be this section. Bird and dog, that's this section right here, is, what did I say, 3? So that's going to be minus 3 plus X. And then plus the unknown X. Alright? So yes, this is what we want to solve for, but we have to realize, I guess, that the X is actually in some other expressions as well. So here's algebraically, again, where we want to solve for X now. Now that we've got it all set up, we solve for X. Okay? So at this point, I'm going to turn it over to you. Alright? I want you to solve for X given this. So I've got you this far. Solve for X, because this is actually important that you guys know how to solve for X here. This is some basic algebra skills that you need to know how to do. So go ahead and take a minute. I'm going to pause here. I'm going to freeze the screen. You guys solve for X. Okay? And try not to look at the textbook because it is all worked out in the solutions. Don't look at the textbook. Just give it a try on your own. Okay? Go ahead and do that for a minute. Alright, so this is what you want to do algebraically to solve. You should have gotten X equals 1 when you solve for X here. So which means that there's 1 child with all 3 pets. That is the answer to this question for A. Okay, that's the answer for A. Now, I don't know if I need to go over this or not, but one tricky thing here you want to make sure that you understand is that when we subtract more than one term, that negative sign has to distribute. Okay, so we're actually subtracting 2 and we're subtracting x. So that's why I have minus 2 minus x, and for all three of these. So minus 4 minus x minus 3 minus x. So I highlighted the numbers. So 39 minus 2 is 37, minus 4 is 33, minus 3 is 30. And then we have negative 1x, negative 2x, negative 3x, plus 1x is negative 2x. Subtract 30 from both sides, you get negative 2 equals negative 2x, x equals 1. Okay? So this kind of thing in Foundations 30 you need to know how to do. If you are struggling with algebra and solving for a variable like this, you need to come talk to me. Alright? Come talk to me after class or at noon or whatever, and I'll go over some of this stuff with you. But you need to know how to do this, okay? Alright, any questions? Alright, so as we move through the textbook here, there are obviously Venn diagrams with, they can have as many subsets as possible. I mean, really, there's no end to it. Each section means a different thing. And again, this is an example where there's lots of different subsets here. The idea is the same as we've taken a look at. Okay, this is a good example to go through if you're still a little unsure. I would suggest you working through this example. I am going to give you your assignment shortly here. So if you need some help, again, we can go through another example, and I might do that just with you if you're having trouble. You can use the algebra method, or you can use this. See, here's the Venn diagram method. Start with the number in the middle and work out. Okay, that's the best way to do that. All right, so the key ideas, just really quickly, before the assignment comes here. Where are they? Here they are. Set theory is useful for solving many types of problems, including internet searches, database queries, data analysis, games, puzzles. Okay, if you search on the internet and you have several words and you want the internet to find documents or websites or whatever with all three of those words, the internet is looking for H right here, right? It's the intersection of all three of those words, right? So think about that in the search. So there's a little bit about what each section means. And here's the principle of inclusion and exclusion with 3 sets. That's the one we just went over in our previous example right here. Okay, so you might want to take another look at that. And there's some more hints for you, and I'll give you your assignments here in a second.